Welcome to Campfire. In our last video, we identified common acids and bases that we find around our home. Today, we're going to be taking a look at how we can identify whether those are strong or weak acids, or if they are strong or weak bases. All right, so what we're going to do is here I have several substances that we're going to be testing. We're going to go ahead and begin with our hydrochloric acid. And in this test tube, I added 2 milliliters of hydrochloric acid. Now first, is hydrochloric acid an acid or a base? All right, the name kind of gives it away. It is an acid. So let's go ahead and just test that with our litmus paper. So we know that if we use blue litmus paper with an acid, that the acid will turn the blue litmus paper, that's right, red. So here I have my blue litmus paper. I'm going to set it on this platter. I'm going to add a drop of the hydrochloric acid to the blue litmus paper. And let's see what happens. Immediately, the blue litmus paper turns red, indicating that it's an acid. But using the litmus paper does not tell us if it is a strong or a weak acid. That's where we need to use something else. In the home, you can make something called red cabbage juice indicator. And in my last video, I told you how you can do that. You just take some red cabbage leaves, distilled water, boil it for a few minutes, and then allow it to cool. Here I have some red cabbage indicator. I'm going to go ahead and take my eyedropper and fill that up. And then I'm going to put several drops in the test tube with the hydrochloric acid. All right. As you can see, the color is changing from clear to a reddish pink color. I'm going to swirl that around. As you can see, that when we add the red cabbage juice indicator, the color has changed from clear to a very bright red. Very bright red, using cabbage juice as an indicator, tells us that hydrochloric acid is a strong acid. You may want to refer to your chemistry textbook, page 405, to see the color chart of many different indicators. You will see that when you're using red cabbage juice indicator, that a very dark red indicates a strong acid. A neutral substance would be the color of the red cabbage juice, purple. And a very strong base is green. We're going to go ahead and test the rest of these. The second substance that I have is sodium hydroxide. Now, sodium hydroxide, we don't know if that's an acid or a base. So we're going to go ahead and we can test that with either red or blue litmus paper. If I take a sheet of blue litmus paper and I add a few drops of my sodium hydroxide, I will see that the blue litmus paper does not turn red. So that tells me that sodium hydroxide is a base. Let's go ahead and test that. I'm going to take a sheet of red litmus paper and I will put a few drops of the sodium hydroxide on the red litmus paper. And when I do that, immediately the red litmus paper turns blue, telling me that the sodium hydroxide is a base. But the litmus paper doesn't tell us if sodium hydroxide is a strong or weak base. We can use our red cabbage juice to tell us that. I'm going to take my eyedropper and fill it up. Then take my sodium hydroxide test tube and add several eyedroppers of red cabbage juice to the sodium hydroxide. You will notice that the clear liquid is changing to green, and the more cabbage juice that I add, the more intense that green color becomes. So here we have the two extremes. We have a very strong acid, hydrochloric acid, and we have a very strong base, sodium hydroxide. Now on the pH scale, a strong acid is going to be found from 0 to 6. 7 is a neutral substance. Bases are going to be from 8 to 14. Now let's test some other known household substances to find out how strong of an acid or how strong of a base they are. In this test tube, I have vinegar. If you think about recipes that have vinegar in it, it does have a sour taste. And so if you recall the characteristics of acids, acids do taste sour. But let's go ahead and first test that with some litmus paper. I put some vinegar on this saucer. And so if I think vinegar is an acid, I'm going to test it with my blue litmus paper. And when I dip my blue litmus paper into the vinegar, it immediately turns red, indicating that vinegar is indeed an acid. But we don't know how strong of an acid vinegar is. So let's go ahead and use our cabbage juice indicator to show us how strong vinegar is. I'll go ahead and fill up my eyedropper, and we will put this in with the vinegar. And we will see that the vinegar has turned a bright pink color. Let's compare that to our known strong acid, hydrochloric acid, and you'll notice that it's awfully close. So vinegar is a fairly strong acid, measuring 2.5 on the pH scale. Next, I have some ammonia. Ammonia, is that an acid or base? Well, first we can test that with our litmus paper. Let's go ahead and take a sheet of red litmus paper and dip it into the ammonia and see what color it turns. The ammonia turns the red litmus paper blue, indicating that ammonia is a base. Very good. But we don't know how strong or how weak a base ammonia is. So let's go ahead and add our cabbage juice indicator to the test tube with the ammonia in it. And we will see that it is changing colors. It's becoming a green. We will swirl that around. If we compare our ammonia with our known base, sodium hydroxide, we will see that they're very close in color. The ammonia is a little bit lighter green with a tinge of blue. And so ammonia measures like 11 on the pH scale. Our next substance that we want to test is baking soda. This is a powder, so I need to add some distilled water to dissolve it before I can test it. So I'm going to add some distilled water and cover that with my finger and shake it up. Okay, first want to test the baking soda with my litmus paper to find out if it's an acid or a base. So I'm going to take a little bit of this solution of dissolved baking soda and pour it on my plate. Then I'll take a sheet of red litmus paper and I'll dip it into my solution, and I'll see that right away it turns blue. So this tells me that if red litmus paper turns blue, that substance is a base. But I don't know, or it doesn't tell me, if it's a strong base or a weak base. So we can use our red cabbage juice indicator to tell us if the baking soda solution is a strong base or a weak base. To do that, I'm going to fill up my eyedropper with some red cabbage juice indicator, and I'm going to add that to my test tube. And I can see that it is changing colors, and it's a really pretty blue. We'll swirl that around so you can see. So here we have the baking soda solution, a bluish green. So baking soda is a 9 on the pH scale. Here I have lemon juice. Now from experience, we know that lemon juice tastes sour. And so from the characteristics of acids and bases, which one tastes sour? That's right, acids. So let's see how strong of an acid lemon juice is. Go ahead and take our cabbage juice indicator and add that to the test tube. And what color do you see it changing? So we see the lemon juice turns a very bright pink color. Let's go ahead and see if we can order these. Our very strong acid was the hydrochloric acid. Then we have the vinegar, and then our lemon juice. See if you can see very slight color changes, but they are noticeable. Next is one of my favorite morning drinks, coffee. Is coffee acidic or basic? Let's go ahead and test a little bit. We are going to put some on this plate. Let's test the coffee with a piece of blue litmus paper. The litmus paper turns red. So that means coffee is an acid. But is it a strong acid or a weak acid? Let's go ahead and use our red cabbage juice indicator to show us. All right, if you take a look at this, it is a murky, reddish, purplish color. Coffee is a weak acid. It's on the high 4s, low 5s of the pH scale. So I'm going to go ahead and put that over here. Next, we have hand soap. So first I need to add a little bit of distilled water so that I can dissolve this hand soap. Add some distilled water, shake that up. Next, we're going to put a little bit on this plate. And we're going to go ahead and test whether hand soap is an acid or a base. Let's take a piece of blue litmus paper and put that in the solution. And let's go ahead and take a piece of red litmus paper and put it in the solution. When I test this hand soap with the litmus paper, the blue litmus paper remains blue and the red litmus paper remains red. So this particular hand soap has a very neutral pH. When I added the red cabbage juice, I can see that it is very similar in color to my red cabbage juice. The last substance that I'm going to test is baking soda. I went ahead and put a little bit of baking soda in this test tube, then added some distilled water and shook it up to dissolve it. I want to test if baking soda is an acid or a base using litmus paper. So I'm going to start with some red litmus paper. I'm going to put a couple drops of that and see if my litmus paper turns color. And I do see that right away my red litmus paper does turn blue. So that tells me that baking soda is a base. But again, I don't know if it's a strong base or a weak base. So that's where I'm going to go ahead and I'm going to add my red cabbage juice indicator. Okay, so here we have a pretty blue color. Baking soda is around 8 on the pH scale. So here we have our very strong sodium hydroxide base. Next, we have our ammonia. Then we have our baking powder. And then we have our baking soda. And you can see that using an indicator like red cabbage juice gives you a better indication of whether the acid is strong